Right. So till yesterday, so we have seen like STLC process, like where we have to start requirement analysis or understanding the requirement, and then test design. So as part of the test design, we have to identify the scenarios, then we have to write the test cases, and we have to prepare the test traceability matrix, right? So they are part of the test designing. And after that, test environment setup, and we have to simulate the environment exactly the same as a customer environment. And then test execution will start. So during test execution, we will execute all the test cases based on the priority, and we'll try to find the defects and we report the defects to the developer. Okay, so that is a process we have discussed. Now today we will discuss more about defects and then uh, test closure phases. So here, yesterday we have seen what is defect, right? What is bug, and what are the defect classifications, like what is severity, what is a priority, and also we have seen different examples, right? So today we are going to see the defect life cycle or bug life cycle, and then rest of the topics. So let me just share small presentation. What is defect life cycle? So defect life cycle basically says the state of the defect. Okay. So defect life cycle always says the state of the defect. In which state the defect is depends upon the situation. The state of the defect will be changed. We can also call it as a defect life cycle or bug life cycle. Okay. So let us see what are the different states we have for bug life cycle. So whenever a tester raised a bug, okay, whenever a tester raised a bug, that will be in the new state. Okay, the new bug will be in the new state. There's a first state of the bug. This is a new state. After that, what happens from the developer's team? Sometimes this is not mandatory, but sometimes a dev project manager analyze the bug. So even like test manager, similarly development side, there is a development manager also will be there. So there will be different ways we can send a bug, guys. So sometimes developer to developer, so directly we'll go to the from developer to developer. So sometimes what happens is from tester to test manager, and test manager to development manager, and then development manager will assign the bug to the particular developer. Okay, so sometimes the communication will be like this. It depends on the company how the process is designed. Okay, so here I'm just taking the manager also, considering manager. So dev project manager analyze the bug. Whatever bug we reported, the development manager will analyze the bug. And if that bug is valid, if the bug is valid, then they will test two to three phases. Like if the bug is valid, then they will check that bug is already existed previously. If it is already existed, then they will duplicate. So if the bug is not valid, bug will be rejected. So the status will be changed as a rejected. If it is not valid, so if it is a valid, then they will check again the bug is already existed or not. If bug is already existed, then they will change the status as a duplicate, because that's the bug is already existed. If bug is not existed, then delayed means what? They will keep that bug in the queue. So before that we reported multiple bugs, they are currently working on them. So after completion of those bug fixes, then they will take up this new bug. So the delayed means deferred. So they put delayed status, that means they put status as a deferred, means what? The bugs are in the queue, delayed. And if the delayed is no, means there is no delay, there is no other bugs in the queue, then they will assign the bug to the particular developer. Means the developer start fixing the bug. So then assign status will be assigned to the bug. Now when a bug is in assign state, means what? The developer is trying to fix the bug, or developer is currently working on the bug. Now dev start fixing the bug, then status will be changed into open state. So after opening state, then developer fix the bug. After developer is fixed the bug, then status will be changed as a fixed. And once the status as a change as a fixed, then tester retest the defect. And once the tester is retested, then if it is working fine, then we close the defect and status will be in the close. Suppose while retesting the defect, something is got again fail. Again, we will reopen the defect and same process will continue. After closing the defect, again in the coming builds, we will perform the regression testing. Again, if the regression testing, if the bug is failed, again we reopen and continue the same process. So this is the entire bug life cycle. So bug status will be changed depends upon the situation from new to rejected or duplicate or deferred or assigned, open, fixed and closed. So by seeing the status, we can understand in which state the bug is available. It is just like a tracking purpose. So automatically the status will be changed. Like developer will update the status. So for example, as soon as I raise a bug, the tool will automatically assign the status as a new, and then developer can select these statuses. Suppose he don't want to fix that bug, or he's not thinking that's a valid bug, then he can put rejected status, or he can change into duplicate, or he can change into default, he can change into assign. And after bug is fixed, then he will change the status as a fixed, and then we have to check the status, and accordingly we have to retest the defect in the next coming build or bug fix build. Then if it is working, we have to close the defect. So this process is basically called as bug life cycle or defect life cycle. Very, very important interview question. Definitely people will ask in interview, what is bug life cycle or defect life cycle? Then you have to explain all these things. Okay. So suppose sometimes bug is rejected. Okay. Sometimes you bug is rejected. Then what could be the reasons? So sometimes if the bug is rejected, then the reason could be the enhancement. Suppose whatever bug you reported, the developers are thinking that is a enhancement, not exactly a bug. That is enhancement. Enhancement means what? In coming versions, they will implement that as a feature, or they'll implement as a functionality. So that is called as enhancement. So they will reject that bug because the dev is thinking that that is an enhancement. And sometimes need more information. Sometimes whatever the information you provided to the developer related to the defect, which is not enough to understand the defect and which is not enough to fix the bug. In that case also, the developer may reject the bug, or he asked for the new information, he asked for more information, and not reproducible. Sometimes the developer cannot reproduce the bug in their environment. So based on the steps we have based on the steps we have shared with them. So once they executed the same step, they are not able to reproduce the bug in their environment. In that case also, they reject the bug. And in that case, they will update the status as not reproducible. Sometimes they reject the bug because of as designed. So whatever bug we reported, that is not exactly bug, that is working as per the design. In that case also, developer may reject the bug. So in interview, people may ask you why, what are the different cases, or what are the different situations the developer reject the bug. In that case, you have to tell it. It may be enhancement, or it can be something called need more information, or it is not able to reproduce and then as per the design. In these cases, developer reject the bug. Okay. So this is all about bug life cycle or defect life cycle. So as soon as the bug is fixed, then immediately we have to retest it. And we can also do the regression test. If it is working fine, then close the defect. If it is not working fine, again reopen the defect, again it will come to the beginning. Open the defect, again dev will fix, again change the status as a fixed. That's it. So reopen. So but again it will not follow entire thing, only this particular process will follow if bug is reopened. So we reopen means what? Developer is already fixed earlier. Fixed means what? That is already crossed all the statuses. Developer is accepted, developer is worked on that, everything is already processed. So only the opening, fix and close, only these three processes will continue if bug is reopened. Until unless the bug is fixed, we keep on open the bug and make sure that is a fixed, track the defect, and if it is working, then finally we close the bug. Until unless it is working, we should not close the bug. Remember, guys. Okay. Okay. Suppose the same bug is repeated in upcoming builds. Then what you have to do? Suppose in this build your bug is fixed and working fine. You have closed it. Then In the upcoming builds, again, same bug is repeated. Then you have to raise a new bug. You cannot reopen the closed bug. Okay, so you can also, but you can do that also, but it will not count, right? So if you already reported one bug which is already closed and working fine in one build, and in upcoming build somewhere after two builds or three builds, somewhere that functionality got affected, then what you have to do, instead of reopening the same defect, because in between there are multiple builds or came, so you have tested the functionality between 2 to 3 builds and working fine. So instead of reopening the old defect, again you can raise a one more defect by specifying the bill number. Okay, then the count will be increased. Okay, so you have to raise as many bugs as possible, and most of them are should be valid bugs. It should not be the invalid bugs. Okay, so this is all about bug life cycle. Then let's move on to the next concept. So test cycle closure. So this is the last phase of STLC. So the first phase is understanding requirements, and the next phase is test design or implementation, then test environment setup and execution, then bug reporting and tracking, and finally test cycle closure or test closure. So this is the last phase of STLC. So here we do certain number of activities in the test closure. So what exactly test closure means? Here we'll stop our testing. Okay, we will stop our testing. So when we have to stop our testing, okay, so when we have to stop our testing, so we have certain criteria. So once we met that criteria, we have to stop our testing. So for example, you have 100 test cases. So once you executed all 100 test cases, right, and all of them are got passed and the bugs are closed, we can stop our testing. That is a one criteria. And what is the other criteria is the application should not have any bugs. Application should not have any bugs means what? You may have one or two minor bugs. Okay, even the company is also allowed, but we cannot release 100% quality product, guys. Okay, this is a, one of the standard or one of the principle in software testing. Even though if you do any exhaustive testing, you can spend any number of days, at least one or two bugs will be there. You cannot 100% release quality product. Okay, so but they are fine, but there should be minor bugs that should not impact any customer business workflow. That is most important. Okay, so based on those criterias, we will stop our testing. So but before stop our testing, what we have to do is we will conduct a meeting with all the team members, like testing team, development team, everything, and make sure all the test cases are executed or not, all the test cases are passed or not, all bugs are closed or not, and test cycles are completed or not. So we will review all these items as a parameters, and we consider them as a exit criteria. And then if everything is fine, then we will close the testing. We'll stop the testing. Okay. So this is a simple test cycle closure. And what is the outcome of this? What are the deliverables? Test closure report and test metrics. So test closure report in the sense is a test summary reports. So we will consolidate all the documents so far we prepared, like including test plan, test scenarios, test cases, the execution report, bugs report, list of bugs. All these things we have to consolidate and keep it as a test summary report, because later we will submit them to the customer. Okay, so this is all about STLC process model, software testing lifecycle process model. Now let us discuss some general things or test metrics. So before that, we have another topic. Let us discuss this test metrics, guys. So which is very, very important. So what is metric means? Why? What is the use of metrics? So whenever you do some task, we have to measure that. We have to track it. So why we have to track that? Because you have to know how much progress it is, how you're progressing, and where are you now, and where we have to go. So that is basically we can measure by using metrics. Okay, whatever task you have done, you have to maintain some metrics which will help the management team exactly how much work is going, how much work is pending, how much work still pending. So the management will exactly know what exactly the status is. For that we have to report some metrics, we have to provide some metrics to the management team. Then what are the metrics we use in the testing process? Now here I have listed some of the metrics, but these are not metrics list. This is the required data we have to collect before writing the metrics. Okay, before writing the metrics we have to collect some data. So what is the data we have to collect? So number of requirements, how many number of requirements we have, average number of test cases we have written per requirement, total number of test cases written for all the requirements, total number of test cases are executed, number of test cases are got passed, number of test cases are got failed. So number of test cases got blocked, number of test cases unexecuted, total number of defects identified, critical defects count, higher defects count, median defects count, low defects count, and customer defects. How many defects raised by the customer in production, number of defects found in UAT, and UAT testing means after completion of system testing, UAT people will start that. How many defects found by UAT? We will collect all this data. This is called metrics. And these are not exactly metrics. We have to collect this data to calculate the metrics. So once you collected this data, based on this particular data, we will have certain metrics. We have to calculate always these metrics in the percentage format. So for example, percentage of test cases executed. How we will calculate? Number of test cases have executed. So tell me the percentage. Then you have to calculate. How to calculate? The formula is the number of test cases executed divided by the total number of test cases of written into 100. So that will give you the percentage of test cases executed. That is the formula. And again, number of test cases executed, total number of test cases written. How we will know that? Before calculating the metric, we have to collect the data here, and then we'll proceed with the metrics. So percentage of test cases executed means number of test cases executed divided by total number of test cases written. That will give you percentage of test cases executed. Then percentage of test cases not executed. So how we will calculate this? Number of test cases not executed divided by total number of test cases written into 100. And the next metric is test cases passed. Everything we will provide in the form of percentage. We should not give exact number. Okay, so percentage of test cases passed. So how we can calculate this? Number of test cases passed divided by total test cases executed into 100. That is percentage of test cases passed. Then percentage of test cases failed. Number of test cases failed divided by total test cases executed into 100. That is called test cases failed. Percentage of test cases failed. And percentage of test cases blocked. So number of test cases got blocked divided by total test cases executed into 100. So these are the few test metrics. Now, these are the defect related metrics. Defect related metrics. Defect density. So what is the defect density means? Number of defects identified per requirement or requirements. So how many number of defects we found per the requirement? That is called as a defect density. So how we can calculate number of defects found divided by number of requirements. And then one more important metric is defect removal efficiency. So people may ask you in interview also. So what are the defect metrics? So you should tell these metrics. Defect removal efficiency means we will have some formula here. Defect removal efficiency. So to calculate this, we have to know three things. What are the fixed defects? How many defects fixed by the developer and how many defects missed by the tester? So sometimes we may miss some defects and those bugs will found by the UAT team in the next phase. So we have to consider those bugs also, missed number of defects. So fixed defects and missed defects, we have to collect the information. Accordingly, we have to prepare one formula. So what is the formula here is fixed defects divided by fixed defects plus missed defects. into 100. Okay. So this is a formula. So here A by A plus B into 100. A means what? Defects identified during defect. Defects identified by the defect identified by the tester during testing phase. They are also called as a fixed defects. And B means what? Defects identified by the customer, means missed defects. If the customer is identified defects means what? We missed those defects during the testing time. So those defects are identified by the customer in the next later stages. So A means what? The defects identified by the tester, or we can say fixed defects. B means what? Defects identified by the customer or missed defects. So the formula is A by A plus B into 100. So this formula will calculate defect removal efficiency, DRE, defect removal efficiency. This is one of the important metric which you have to use for defects. And then defects leakage. What is a defect leakage? So defect leakage means sometimes they are underlying defects which we cannot identify. Okay. And those defects will come after using the software for 1 month, 2 months, 3 months, the defects will come. So those type of defects are called leakage, which is called as a defect leakage, underlying defects. Okay, so how you can calculate that defect leakage? Number of defects found in UAT. UAT means user acceptance testing, divided by number of defects found in testing. So how many defects are found in UAT? How many defects are found in testing? We have to divide and into 100. So that will give you defect leakage. Number of defects found in UAT, number of defects found in testing into 100, which will give you defect leakage. And then defect rejection ratio. This is one of the very, very important metric, guys. Based on this metric only, the management will find invalid bugs. Okay, we should not raise more number of invalid bugs. That will reduce your tester efficiency and your performance. Okay, make sure you have to carefully check once, twice, thrice before reporting the bug to the developer. So if it is become an invalid bug, then defect rejection ratio will be more. That says testers are reported more number of invalid bugs. Unnecessarily, they have wasted time of developers. Okay, so make sure that. So defect rejection ratio means what? Number of defects rejected divided by total number of defects raised. Okay, so into 100. So that will give you defect rejection ratio. And then defect age. How we can calculate defect age? Fixed date minus reported date. So when we have reported, from there to calculate how many days, like fixed date, when it is got fixed. So between how many days we have, that is comes under defect age. Then how to calculate the customer satisfaction? So this is another question, guys. Suppose we are delivering the software to the developer, to the customer. How we will know customer is satisfied or not? So here we will just count the number of complaints. Okay, number of complaints per period of time. So we will have 1 month of month, how many complaints raised by the customer, or between 3 months, how many complaints are raised by the customer. So based on that, we can consider which we can calculate customer satisfaction. Number of complaints per period of time. If there are more number of complaints, that means automatically customer will not be satisfied, right? So that is again a mindset. So these are the different test metrics. And before calculating these metrics, we need to have some data with you. We have to collect some data, and then we can calculate these metrics. And these metrics will be very, very useful for management team. And based on this metric, they will analyze the status of the testing, what exactly happening, and what is completed, what is still pending, how it is going. So these things they will analyze based on this metrics. Okay. All right. So then now let us discuss a general thing like QA and testing activity. So far we have seen a lot of things in testing. So we have understand the testing concepts and STLC process, everything. Now finally, as a QA engineer or as a test engineer, right, we have to know what are the activities we do on day-to-day basis. So once you join in the project in a new company, so what are your roles? what activities you do on day-to-day basis. So you have to be clear on more. You have to be very clear on that. So let us see what are the activities you do on your project. So understanding the requirements and functional specifications of the application. This is a very, very important activity every tester should do. As soon as some feature is assigned to you, you are the responsible for that particular feature from the beginning to end. You have to understand the requirement, you have to prepare the plan, you have to write the test cases, execute everything you have to do for that particular feature. You are the owner of the feature until it delivers to the production. Okay, so understand the requirement is very, very important. So in the beginning days of STLC, they will allocate more time for understanding the requirement. Writing the test cases, test plans takes a lot of time, but even execution also don't have that much of time, because requirement analysis, like understanding the requirement, test planning and designing in the foundation level. So we have to be strong in the foundation, because if you miss anything during design part, we cannot find more bugs in the execution. Okay, so we have to spend more time always on the preparation of test cases, understanding the requirement. So that's the first and most important task of the tester. So understanding the requirements and functional specifications. Identifying the required test scenarios. As soon as you understand the requirement, by reading the requirement, you have to identify the scenarios. We need to identify the test scenarios, means what to test, what are the areas to be tested. We have to identify and we have to list out all the scenarios, and then designing the test cases to validate the applications. After identifying the scenarios, for each scenario, we will write multiple test cases and setting up the test environment or test bed. So before executing the test cases and before getting the build from the developer, we have to set up environment. And once we get the build from the developer, we will install it and we'll proceed with the testing and execute test cases to validate application. And then log the test results. Means what? We have to prepare the execution report, result report. How many test cases are executed, how many are passed, how many are failed. So we have to prepare a small report that is called test log or test results. And defect reporting and tracking. So whenever you report the defect, your job is not completed. You have to track it, in which status the defect is there. You have to keep on looking at the defect. You have to take the ownership of the defect till it is closed. Okay, so you need keep on communicating with the developer regarding the defect. So that is called tracking. So defect reporting and tracking you have to take care. And retest fixed defects of previous build. So whatever bugs or defects you reported in the previous build, after getting the new builds, in the new builds, the developer fix it. So you have to retest them. You have to make sure the defects are properly fixed or working fine or not. And perform various types of testings in the application. So you have to conduct smoke testing, sanity, functional, UI testing. So whatever the types we have discussed earlier, so all the types of testings we have to conduct according to your requirement. Then reports to the test lead about the status of assigned tasks. So every day some task will be assigned to you. At the end of the day, you have to report to the lead or manager. What are the tasks assigned to you and what have completed, what you have not able to complete, and why it is get delayed. So you have to update everything to the lead or manager in your team. Then participate in the regular team meetings. That is a basic responsibility of every team member. So you have to participate in the team meeting, then only you will know the progress, and then only you will know the exactly how what other people are doing in the project, how the project is moving, and in which place the project is currently there, and what else we have to do for the project. So understanding the status, knowing the status is very, very, very important, guys. So for that you have to attend the meeting, and also you should able to explain the status of your project, your feature in the meeting to the management. Creating automation script. If you know automation, then whatever test cases got passed, you can automate immediately, so that in the upcoming builds you no need to execute the same test cases manually. So if automation is already done, so you can execute those automation test cases. They will make sure the retest cases, regression test cases got passed, and rest of the features you can execute manually. Okay. Then provides a recommendation on whether or not the application or system is ready for production. This is another very, very important role. or responsibility of the tester, guys. Okay. Finally, after completion of your whole test cycle, the management will take the opinion from the tester. So are we ready to release the build to the production or not? So you have to give the confirmation. If you are say yes, then only management will proceed to deliver the product. And tester says no means what? The product is not ready yet. Okay, so depends upon the tester decision. The management will decide whether the product is ready for delivery or not. You have to tell because you have conducted testing, you have tested everything, and you know exactly the actual health of the application. So if it is well, then you can just give the green signal and then they proceed further. So that is another very, very important. So these are the main activities normally the tester will do on day-to-day basis. Okay. So understood, guys. Everyone, please confirm in the chat window. Are you clear about activities? What you have to do on testing? Okay. Finally, we will discuss one small topic: principles of software testing. So in the software testing, there are 7 principles are there. Maybe in interview also people may ask you, what are the principles of software testing? There are 7 principles we have in software testing, guys. So what are those principles? So whenever you test the application, it is better to start in the early stages. So we should not sit idle till we get the build from the developer. Okay, we have to start software testing at early stages. Means what? From the understanding requirement. Means we can test the requirement document, we can test the design document, right? Or we can verify the test cases, we can verify the scenarios. Then once you get the build, we'll test the build, smoke testing, sanity testing. These are yearly testing stages. We are not conducting actual testing, we are testing, we have already started testing in the early stages. So that is very, very important. Means from the beginning, when you get the requirements, we have to start our testing. So that's the first principle. Second principle is test the software in order to find the defects. The main intention of conducting the testing is find the defects. Keep in the mind. Your mind always should think about the defects. So you don't think like everything should pass. No. Don't expect everything should pass. Always think in negative way. So you have to find the defect. At the end of the day, that is your job. You have to report some bugs to the developer at the end of the day. So if you're not finding any bugs on day-to-day basis, still you are executing the test cases means what? Like there is no guarantee like you found some bugs. So maybe the bugs will be there. Maybe those bugs will appear in the coming releases. So you have to make sure you conducting the testing only for identifying the bugs, not for anything else. Your concentration is always will be on the defects. That is the second point. So test the software in order to find the defects. Now the third principle is, it's highly impossible to give a bug-free software to the customer. Okay. So in interview, people will ask you, is it possible to deliver 100% bug-free software to the customer? Is it possible? Not at all. It is never possible. Even though if you recruit more number of people, or you can improve, you can improve the duration of the time or duration of the testing, you can add more cycles, still it never ever possible. Because there are some underlying defects, guys, which we cannot find those defects during testing. And those bugs will come after using the software 3 months, 6 months, or 1 year sometimes. And those bugs will come out. So it is very, very difficult to find underlying defects. So we cannot deliver the software 100% quality. Okay, bug-free product. So highly impossible to give the bug-free software to the customer. So next fourth principle is, should not do exhaustive testing. Should not do exhaustive testing. What is exhaustive testing means? Sometimes we use same data for our testing every time. We should not use the same type of data for testing every time. For example, let us say I have a login screen. I provide valid username and valid password. So every time we should not use the same data for login for testing. We have to use a different type of data. Then only we will know whether it's properly working or not. Valid username, valid password, valid username, invalid password, invalid username and valid password. So we have to prepare different combinations of data. Okay, then we can test it. But if you use the same data for testing again and again and again, that is called exhaustive testing. We should not do that. Every time you have to change the data. That is the fourth principle. Now the fifth principle, testing should be context based. Testing should be context based. Means what? Depends upon the application, you have to decide what kind of testing should be conducted. So depends upon the application, you have to decide what kind of testings will be conducted. For example, if it is a web application, so web application means what? Number of people will access through internet. So many people may access the application through internet. So automatically performance will be reduced. So you have to conduct performance testing there for web application. It is mandatorily required. But if you have a desktop application, let's say a notepad or MS Word document, do we really need to conduct performance testing? Not required, because that is installed in your local machine and you are the guy you are using your software. Nobody else accessing that. So that doesn't require performance testing. So your desktop applications doesn't require any performance testing. So we have to decide what kind of testing should be conducted, depends on the context. Context means the type of application. Okay. So testing should be on context based, means decide what types of testing should be conducted based on the type of application. Remember. Okay. Then the sixth principle, we should follow the concept of pesticide paradox. There is a purely technical term, guys. Pesticide paradox. Pesticide paradox means, if you are, suppose today you have some number of test cases, let's say you have 50 test cases or you have 100 test cases have written, and so for functionality. And in the coming cycles or in future, in the next releases also, if you want to test the same functionality, if you are using same kind of test cases in future also every time, that is called as pesticide paradox. Okay, we should not use it actually. So pesticide paradox means what? If you are executing same test cases for longer run, they won't be find any defects. You have to upgrade your test cases every time. Okay, initially at the test designing time, we will have some test cases, we will get approved from that, but we will execute those test cases, but we should not stick to that. If possible, while getting the build also, while executing our test cases also, if you find any other scenarios, if you find any cases, then you can still add those test cases into Excel. Okay, don't ignore them, because our test cases is already approved, everything is freeze. Don't think why should we add a new test cases again, not required. Sometimes in the requirement also you may not find those scenarios. In application you can find it. Okay, consult your product managers and management and consider whether, check whether it's a feature or bug or something. If it is a really feature, then add few more test cases for that in the test case document. So keep on upgrade your document, then conduct the testing. If you are using same test cases from beginning to end, after few many days, after few many months, the same test cases may not find a new defect, because the main intention of writing the test case is finding the defect. The test case should find the defect. So that's the main intention. So here, the sixth point is, we should follow the concept of pesticide paradox. Means if you are executing the same cases for long run, they won't be find any defects. We have to keep update test cases in every cycle or release in order to find more number of defects. This is the sixth principle. Now the seventh principle, the last principle, we should follow defect clustering. So what is the defect clustering means? Suppose you have so many modules in your application, and especially there are few modules, those modules having more number of defects. Okay, more number of defects. Some modules, based upon your experience, you can check it. Suppose you are already working on some projects and you think like so and so modules having more number of defects, and always you focus more on those risky modules. First priority will go to those risky modules. So some of the modules contains most number of defects. So by experience, we can identify such risky modules, and 80% of the problems are found in 20% of the modules. So there are certain modules, in those modules most number of defects we can find, and we'll more concentrate on those particular modules. So that is called defect clustering. Okay, so these are the 7 principles of software testing which we have to follow. So let me repeat a few, fourth and sixth point. The fourth point is should not do exhaustive testing. Exhaustive testing means what? For one test case, we should not use same kind of data again and again. I also given one example. If you have a login test, if you have a login screen, to test the login screen, valid username, valid password, you will use it. But same username, same password, you should not use every time for testing. You have to prepare some other test data, and different type of data you have to use. For example, I have given one calculator to you and ask you to test the calculator. So what you will do? I ask you to test the addition of two numbers. Then what you will do? First you will enter 1, then plus 2, then equal to. So you are getting 1 plus 2, 3 or not. You will test it. That is one type of data. But every time you will not give 1, 2, right? Next time you can change the numbers. You can change -2 or -1 or 5 or 3 or 10 or 15. Then 3 digits, 4 digits. So you have to test the application with a different type of data, but we should not use same type of data. That is, if you use same type of data, that is exhaustive testing. Okay, if you use same type of data every time, that is called exhaustive testing. We should not do that. That is a principle. We should not do the exhaustive testing. We have to change the data every time. That is a fourth principle. Okay, and sixth principle is we should follow concept of pesticide paradox. Pesticide paradox means what? We have to keep on upgrade your test cases, keep on add few number of test cases or modify existing number of test cases. Same test cases we should not use for longer run. Suppose your project is 10 months, and 10 months before you created some test cases, and during the 10 months of period your application is adding lot many features, and some existing features are got removed, and some existing features are got modified. Accordingly, you should also change your test cases. If you are not changing the test cases, you cannot find the defects in those changes in your application. So that is the sixth principle. So that is called pesticide products means what? You have to keep on upgrade your test cases. Same test cases will not run, no longer works. It won't be find any defects in your application. So that's the reason you keep update your test cases in every cycle or in every release in order to find the more number of defects. So these are the 7 principles we have to follow in software testing. Very, very important question in interview. Okay. So with this, we have completed module 1. Okay. So far we have seen software testing concepts, and STLC, the process also we have discussed. So please prepare all these topics which are very, very important. So with this, we have completed theoretical part. So theory is over. So based upon this knowledge, we are slowly entering into the practical part. So from the next session, we are going to see software testing projects. So how we can implement all these concepts practically in your application. So that we are going to start from the next session. Okay.